Welcome to lesson 1-3. We are now looking at angle bisectors. An angle bisector is a ray that cuts an angle into two congruent or two equal parts. So two equal angles. A ray that cuts an angle into two congruent or two equal parts. So we have an angle here, and I'm just going to sketch it. I'm not going to draw it. To draw it, I would actually use a compass, and that's something we're going to be doing at the end of this lesson. So this is a nice little sketch of an angle bisector. BK, Burger King, is bisecting this angle, so it would actually create two congruent arc marks. BK bisects, let's call this angle ABC. So this is the notation I would use. BK bisects angle ABC. In the picture, to indicate that it is a bisector, I draw the congruent arc marks. Finding the measure of an angle, example 4, using angle bisectors. KM bisects angle JKL. Well, they don't give us a picture for this, so we're going to have to draw it. I'm going to start with the angle which is bisected. I'm going to draw that over here. I have JKL. JKL, and those don't look very straight, but we're going to pretend they are. KM, here's K, it's at the vertex. M bisects it, which means this piece and this piece are equal. So now I'm going to fill in my expressions. I have the measure of angle JKM, that expression is 4x plus 6. And MKL is 7x minus 12. Well, I have an expression for this piece, an expression for this piece. This plus this will add up to the whole thing, which is not what we're being asked to find though. But because it's been bisected, those two pieces are equal. So I can start my proof by saying the measure of, well actually what I should start with is this first thing, that it's been bisected. That's our given. Line 2 will be that the measure of angle JKM equals the measure of angle MKL. The reason being the definition of angle bisector, because that's a definition we defined up top, told us that those two pieces would be equal. That's why they're marked congruent there. And so, or I can say they're congruent, but then I have to say that they're equal as a next line. So I'm just going to do this in one step. The measures are equal by definition of angle bisector. And now I'm going to plug in the expressions. Angle JKM is 4x plus 6. MKL is 7x minus 12. So since I plugged it in, it is substitution. We're going to solve, so getting my variable to one side, I have 6 equals 3x minus 12. I just used subtraction property of equality. Next I'm going to add 12, so I have 18 equals 3x. So that's going to be, since I added, it's the addition property of equality. And now I'm going to divide by 3. So 6 equals x. That is the division property of equality. And lastly, we're going to plug it back in to find what we were supposed to, the measure of angle JKM, which is the expression 4x plus 6. So we're going to use substitution to do this. And we're going to plug in our answer of 6. 4 times 6 is 24, plus 6 is 30. So the measure of JKM is 30 degrees. And if they just asked this as a general question, I would just do this algebra here and solve and get my answer. But because they asked it as a proof, we have to start with this statement and justify every new equation that we write. All right, let's take a look at letter B. JK bisects angle J, or LJM. So I'm going to start by drawing an LJM. J is in the middle, so it's my vertex. And it says JK, that's no joke, bisects it. So LJK, this angle, has an expression of negative 5x plus 3 halves. And KJM has an expression of negative x over 2 plus 21 over 2. Oh, this will be fun with fractions. We're not going to write it. We're going to start it as a proof. We're going to change the directions to start as a proof so that we set it up the right way, but I know you know how to justify your algebra reasons, so I'm going to leave it alone for now. So starting this as a proof, I would start by saying, hey, they said that JK bisects LJM. So that's the given. Step 2 would be that angle LJK, the measure of angle LJK, is equal to the measure of KJM. How do I know that? I know that because they said it is bisected, and to bisect means to cut into 2 equal parts. So this is definition of angle bisector. At this point I would plug in, and I'm going to stop writing it as a proof just so we can solve it quickly. Negative 5x plus 3 halves equals negative x over 2 plus 21 halves. We've done that by substitution. All right, we don't like that there are fractions, so we're going to multiply everything on both sides by 2, giving us negative 10x plus 3 equals the opposite of x plus 21. I'm going to get our variable to one side, so now I have 3 equals 9x plus 21. I'm going to subtract 21 to get negative 18. And divide by 9 to get x equals negative 2. That's great, but that's not what they asked us to find. They asked us to find angle LJM, which is the whole thing. So we're going to have to plug it into both expressions. So this one right here, negative 5 times negative 2 plus 3 halves. They should be the same, but I'm going to check it anyhow. The opposite of negative 2 over 2 plus 21 over 2. So let's try this. This is going to be 10 plus 3 halves. It's going to be 11.5 or 11 and a half. 2 over 1, or 2 over 2, which is 1, plus 21 halves, which is 10.5, plus 1 is also 11 and a half. So that means that if I add the two together using the angle addition postulate, which we're not writing as a proof right now, the measure of angle LJM would be 22.5 degrees when I put the two angles together to get the whole angle. This concludes the video notes for lesson 1.3. We'll be working on the try it problems and practice in class. Have a great day.